This video is going to recap oxides which you learned about last year. So the periodic table gives us lots of information about the elements, in particular the position where that element is tells us something about it. For example, we've got along the ladder the metalloids here, to the left of the metalloids are the metals, and to the right we have the non-metals. But remember, it's not strictly limited to these ones being metalloids, there are a few others accepted as well. Now this is important because what type of element it is will determine what type of oxide it forms. For example, acidic oxides, they are normally formed from non-metals, and when they react with different types of substances, they'll react in different ways. For example, if they react with hydroxide ions, they're going to produce what's called an oxyanion, and if they react with water, they're going to produce what's called an oxyacid. Now, acidic oxides themselves tend to be covalent compounds, whether it's covalent molecular or covalent continuous. Now, what this means, an oxyanion is a negatively charged ion of an element and oxygen. Basically just a non-metal combined with oxygen tends to have a charge, that's why it's an anion. An oxyacid is, as it says, an acid. So as you see, the oxyanions, we've got, for example, carbonate, CO3 2-. The oxyacid equivalent, that 2- is balanced out with 2 hydrogens to form carbonic acid. Whereas the sulfate ion becomes sulfuric acid, and we've also got aluminate at the top. But it follows a similar pattern. So an acidic oxide reacting with hydroxide ions will produce an oxyanion. Acidic oxide reacting with water produces the oxyacid. This is an example. So in this beaker, we're adding carbon dioxide or dry ice to a tub of water. It started off purple because it had universal indicator in it, so it started off at quite basic pH, and then it's starting to change to a lighter yellow color. So as the carbon dioxide, the dry ice, reacts with the water, we're producing carbonic acid. Probably started off a little bit more basic because it was purple, but as we can see, there's now that really yellow color in there. Another example, so this started off as green, so green probably neutral, and sulfur dioxide gas is being bubbled in there. So sulfur dioxide is SO2, and it's reacting with the water to produce an oxyacid. And we can tell that because now it's a nice red color. The pH of acids tends to be around red. So just to show the recap of that, so carbon dioxide plus water makes carbonic acid. We've got sulfur dioxide, it makes sulfurous acid. Sulfur trioxide makes sulfuric acid. Phosphorus pentoxide, P4O10, that one makes phosphoric acid. And then silicon dioxide is another acidic oxide, however that one does not react with water. And that one makes sense because silicon dioxide is basically sand. Sand doesn't really dissolve in water. So they follow a pattern. So it starts off, you've got your acidic oxide, and then when it reacts with water, you're forming the acid from that compound. So carbon dioxide forms like the carbonate, but it's got the 2 hydrogens to balance out, etc., etc. The only difference is that phosphorus pentoxide doesn't really follow that same pattern, but you do have the PO in there, and that makes like a phosphate anion, which gets balanced out by the hydrogen. On the other side, we've got reacting with a hydroxide ion, so carbon dioxide, sulfur dioxide, sulfur trioxide, etc., etc. Now, in this situation, silicon dioxide can react with the hydroxide ion to produce water and silicate anion. So this time when we're reacting acidic oxide with a hydroxide, we actually get water and an anion produced. But this makes sense because remember we said that these acidic oxides they're acidic, so the non-metal oxides are acidic. They're reacting with hydroxides, which are predominantly a base, and when you have an acid and a base reacting together, you usually get a salt and water. Now, these are just hydroxide ions, but we know that when we react two substances together, we're not just reacting hydroxide ions. There would be some sort of metal cation balancing this out, for example, sodium hydroxide. And so really what we're looking at here is the ionic equation for that. So you might have carbon dioxide plus sodium hydroxide going to water and a salt, which would be sodium carbonate. So this is just taking out that extra metal cation. We've also got the basic oxides. So basic oxides are formed from metals or metal oxides. So metals tend to be basic, and when they react with an acid, they produce a cation, and if they react with water, they're going to produce hydroxide ions. The basic oxides tend to be ionic compounds, whereas the acidic oxides were covalent compounds. So for example, starting off with water, magnesium oxide reacting with water will make magnesium hydroxide. Sodium oxide, sodium hydroxide. Now, two exceptions to that, copper oxide and iron oxide, when they react with water, they have no reaction. Remember, if it's not going to react, you have to write no reaction, and that is because they are insoluble in water. So if it's insoluble in water, you cannot react with it. Alternatively, the basic oxide plus an acid, so a H plus, a proton, is basically an acid. So if we react our basic oxide with an acid-base reaction normally gives us a salt plus water. In this case, we're doing that ionic equation again, so instead of getting a salt, we're just getting that metal cation. But if this was, say, hydrochloric acid, you would have magnesium oxide plus hydrochloric acid going to magnesium chloride, the extra chlorine from the hydrochloric acid balancing out the salt, and then water. So similar pattern, sodium oxide, copper oxide, and iron oxide. This time, these will react with the acids because they will undergo an acid-base type reaction. We also have one last type of oxide, and that is an amphoteric oxide. So they are formed from metalloids, and they can act as an acid or a base, or rather an acidic oxide or a basic oxide. It just depends on what they're reacting with. So if they are going to react with hydrogen ions, so if they're reacting with something that's acidic, they're going to act as a base, and if they're reacting with something that is basic, they're going to act as an acid. However, the amphoteric oxides do not react with water. So looking at an example of this, the two most common ones are zinc oxide and aluminium oxide. So zinc oxide plus H+. So the H+ is an acidic substance, so this will act as a base. And if it's acting as a base, you're going to get metal cation and water. But regardless, you're just doing an acid-base reaction, so you're going to get a salt and water out of that. So in this case, this is an ionic equation, so you're going to react with H+ to get zinc 2+. However, if you're doing aluminium oxide, you're going to get the aluminium cation out. Looking at the other example, so if we have a reaction with a hydroxide, this is a basic substance, so it's going to act as an acid. Now, we said before that acidic oxides react with hydroxides to form an oxyanion, so like carbon dioxide formed a carbonate. Here we have zinc 8, so zinc 8 and aluminate, so they don't quite follow the same pattern as the other acidic oxides, but the best way to remember this is that to go from to form the oxyanion, you're basically adding on an oxygen, or getting two oxygens and a 2- up the top. So zinc oxide forms ZnO2 2 negative, aluminium oxide forms AlO2 2 negative. So this is called zinc 8, this is called aluminate, and those are two examples of amphoteric oxides. So here's a summary table of those type of reactions. So if you've got an acidic oxide and you're reacting it with a base or a hydroxide, you're going to get water and a salt. An acidic oxide plus water, you're going to get an acid out. Basic oxide plus acid, water and a salt. Basic oxide plus water, you're going to get a base out, or a type of hydroxide compound. And then amphoteric oxide plus acid, water and salt. Amphoteric oxide plus base, water and salt. And then when it reacts with water, no reaction. So you can stop the video here if you want, or you can have a go at some practice questions. So here, you would pause the video here, have a look at the questions, have a go at writing down what you think the fully balanced chemical reaction would be, and then have a look. So pause the video here, have a go at those three, and then have a look. So the answer to the first one would be CO2 plus MgOH2 goes to water and magnesium carbonate. Second one, we've got sulfur trioxide plus sodium hydroxide goes to water and sodium sulfate. And then silicon dioxide plus potassium hydroxide goes to water and potassium silicate. Another bunch of examples. So this one is looking at hydrochloric acid and magnesium oxide, sodium oxide and ferric oxide. So these are some basic oxides. So pause the video here, have a go, and then have a look. So here are the answers. So hydrochloric acid plus magnesium oxide goes to water plus magnesium chloride, water and sodium sulfate, water and iron nitrate. And then last lot of practice questions. So these are with our amphoteric oxides. So aluminium oxide plus hydrochloric acid and zinc oxide and sodium hydroxide. So pause the video, have a go. And so the answers for these ones are here on the screen. So water and aluminium chloride, and then sodium zincate, or sorry, sodium zincate, and water.